Hello, Stan Young. I want to thank the Heartland. This is one of the most unnerving conferences I've ever been to. People are very smart, very polite. They're trying to cooperate. I'm a rabble-rouser. This is entirely unnerving. But I'll start and be happy to answer questions, and then I do have a handout too that I'll give you if you're interested. When presented with an ethical dilemma, be sure to question the point of view of the individual and the point of view of society. What is good for the individual is not necessarily good for society, and vice versa. So when you look at an argument, you should think of it from those 2 points of view. Also, when looking at an argument, you need to look at the intellectual quality of the argument, and you need to look at the emotional quality of the argument. Is the person arguing with you from an emotional point of view, or are they arguing you from facts and data? I'm a statistician, so I'm a facts and data guy. So that's what you'll hear here. Let's go. Fact, law, and emotion. I'm going to talk about a large data set with the best statistical methods, and then the scare tactics that are often used by the EPA. It's a lawyer joke. In a case, if the facts are on your side, use them. If the facts are not on your side, appeal to the law. If neither the facts or the law are on your side, appeal to emotion. So we need to watch those sorts of things. Keep myself going here. Okay. You'll be able to get the slides with the words. We should really just have the slides here, but we can go ahead. The data. The data actually came about because Steve Malloy and myself were trying to get data to look at the data that came from the papers that were doing air pollution studies. Basically, very few, if any, of the people would give us their data sets. Well, I'm a data methods guy, and so I can't check the veracity of a claim in a paper legitimately unless I have access to the data. So we secured probably one of the biggest data sets on the planet for looking at the question of air pollution. 8 California air basins, 13 years of data, daily deaths. We have electronic death certificates for everyone in California, 37,000 days of exposure, over 2 million death certificates. This data set was looked at by myself and 2 other statisticians to see if we could make sense out of what was going on. We used 2 classic techniques, which I will not go into in any detail: case crossover and time series analysis. And then we added a little flavor to what was going on in the standard things. We would run the analysis by holding one of the 13 years out. And then we would build predictions from the other 12 years, and then we would see how well we could predict the year that was held out. This classic hold one out kind of a thing. We're trying to look at the reliability of the mathematical modeling that's used to examine the data. Emotion. The whole aim of practical politics is to keep the population alarmed and hence clamorous to be led to safety by menacing it with endless series of hobgoblins, all of them imaginary. This was said by H.L. Mencken probably 30 or 40 years ago. And it's an effective tool that is still used extensively. I would make the case, based on the data that I've looked at, that the threats of air pollution, PM 2.5 and ozone on deaths, is imaginary, and I have the data to back that up. Based on things I've heard here and things I've read, I think climate is also an imaginary problem. Let's look quickly at case crossover. So this is statistics in words for you people. You all remember the median. So you take the data, you sort it, and you find the middle value. That's the median. It's another way of measuring the central tendency of the data. So we have a time series that goes for 4,000 days, 4,800 days. So we apply a moving median. We take the first 21 days, we find the median, and then we check the value at that median value against the other values in the data sets, like looking at a little deviation from the median. Then we move it over and we do it again. So as we sweep across the data, we find the deviation from the median as we go across the data. We do that for deaths. We're saying, how many deaths do we see today relative to deaths that are in the same time neighborhood? We do that for air pollution, and we do it for temperature and things like that. So we're looking for deviations from this moving median trend. Well, this is one of the most spectacular non-effect studies I've ever seen in my life. Normally, to publish something, you have to find something, okay? Because so many other people have found things with air pollution, this graph is absolutely spectacular. So look at the y-axis. The y-axis gives the deviations of deaths on a particular day. Each dot represents a day. So the higher you are on the y-axis, the more deaths they are that day. The lower you are, the less deaths on that day. Now, in the picture on your left, we have PM 2.5, this mythical tiny particle that is going to kill you. To the right on the x-axis, we have high levels of PM 2.5. To the left, we have low levels of PM 2.5. This is a spectacular demonstration of no effect. As you see, if there were an effect, what you would see is you'd see the dots sweeping from lower left to upper right. What you actually see is the dots just going straight across the page, no effect of PM 2.5 on daily deaths. The picture on the right is the same picture, but for ozone. So ozone is not killing anyone either. Again, on the y-axis, high would be more deaths, low would be less deaths. To the left would be low levels of ozone, to the right would be high levels of ozone. The other thing that's spectacular about this is note that the no effect goes all the way across the spectrum. There is no low dose that's killing people, there's no high dose that's killing people. This is a spectacular no effect level. We next used a method, time series regression, which is a deeply technical, statistical, kind of way to intensely look at, is there really an effect there? This was computed not only on the California data set, but my co-author, Richard Smith, was so amazed by the no effect, he went over immediately and picked up another data set, the NMAPS data set, extracted all the California data and checked the California data out in a second data set. The end result of all of that is no effect. Here are his two very spectacular graphs. This graph is for PM 2.5. The central black line is the absolutely no effect line. The red wavy line is a spline line that's trying to fit what's going on as you sweep across the data. You see that the spline line is tracking right along the no effect line. The dashed lines are confidence bounds on the spline line. The confidence bounds entirely include the no effect line. Again, deaths up and down on the left axis, and we're looking here at PM 2.5, low is to the left and high is to the right. An absolutely amazingly spectacular no effect line. Here we have the same mathematical technology applied to the ozone data. Again, the black line is no effect, absolutely zero line. The red wiggly line is the spline fit as you sweep across that data trying to find the best line to represent what's going on. And the dashed lines, again, are the confidence bounds on the spline line. The confidence bounds on the spline line include the no effect line. There is no effect here. And again, spectacularly, the no effect carries all the way down to the lowest levels. goes from the lowest levels to the highest levels, no effect. We had a very ambitious younger PhD working with us, very bright young guy, Kenny Lapiano, and we talked back and forth when we were looking at this data, and we said to ourselves, we need to check the reliability of our analysis. And one way to check the reliability of the analysis is to use part of the data to fit a model and then see if that model will predict the part that you left out. So in turn, we left out each of the years and predicted it from the other 11 years. Now, we actually left out the year 2000 because there were a lot of missing data and that would kind of mess up what we were doing. But we looked at the other 12 years and leaving one out at a time. Now, the thing that's really remarkable on these series of graphs, you see the little dots, those are the daily deaths. The red smear line going through it is the prediction from the model. Now, there are a couple of things you ought to note right away. The model is not really capturing much of the variability that's going on with the data. So the models are poorly predictive. The other thing that you can't see that I'll tell you is that one of our models simply used time. It's well known that deaths are higher in the winter and lower in the summer. So if you use a model that only includes time, you get essentially as good a model as you do adding any other thing to it. So adding ozone or adding PM 2.5 does not appreciably improve the modeling process. We've got a lot of supporting literature. I'll give you my email address at the end. Anyone that's technical that wants to look at this, happy to provide information. I do note number 3 here, the 2005 paper by Enstrom. I'm looking at acute deaths. Does air pollution now or 2 or 3 days previous have a chance of killing you? Jim looked at chronic effects. Does air pollution over time kill you? We've both come to the same conclusion. There is no effect in California. My current hypothesis is that there is no acute or chronic effect on deaths in California. And I call this a fact. We have the biggest data set on the planet for looking at this, and there is no effect. Any effects that are observed in the rest of the country are probably due to other factors. Difference in demographics, difference in income, difference in something else. So you will see papers that say air pollution is killing in New York State. It's not air pollution, it's something else. Because the air pollution, if air pollution was a killer, it would be killing everywhere. And the fact that we've established that it's not killing in California puts every other paper at risk for the claims that they have made. Summary. The empirical evidence is that current levels of air quality, ozone, PM 2.5, are not causally related to acute deaths in California. This paper's been submitted. We'll probably have to have a little tussles with the referees and the editors, but hopefully the paper will be out in a couple of weeks or so, or a couple of months maybe, I don't know. Okay, at this point, what can you do? I think you ought to get irate. I mean, I've been here a lot, and there's a lot of stuff that people ought to get irate about. Write your congressman and support the Secret Science Act. The very first part of science is replicability. And you can't have replicability unless other scientists can look at the data. And right now, there's a little secret wink, wink, nod, nod agreement between the EPA and the people they fund. We will give you money, you will make claims that support us, but you will not give the data to anyone. We went to a great deal of trouble to get this data set. If you send me an email, I'll send you the paper once it comes out. CPP, clean power plant is supposed to cost between $40 and $70 billion per year. That's $240 per person per year. Now, I have other data that says that if you charge me $240 per year, well, I think of it pretty crudely. That's a beer a day, okay? And anyone that's going to take a beer a day away from me, they're going to get a letter to their congressman. All right, now, the other way to look at it is if I look at my sort of extended family, that gets to $1,000, $2,000. That's a very good bike. I love bike riding, and I don't want anyone to take a good bike away from me. You have your own personal uses of money, and you should be using your own money. The EPA should not be taking your money away from you for what amounts to no benefit. And I think got one more. Yeah, this is my email address, and I respond pretty quickly to emails. If you have questions, feel free, and I'll send you any information. I do have a one-page handout, so after the thing is over, if you want some of the summary of what I've said, I'm happy to give it to you. And thank you very much for your attention.